Next problem here is actually gives all this information, but it just wants the degrees of freedom. So remember, the degrees of freedom is the sample size minus 1, and it looks like the sample size is 17. So my degrees of freedom would be 16. All right, then it says we're evaluating the service level provided to walk-in customers. Minimize the variance of waiting time for these, since the staff would mean each customer received the same level of service. According to his staff, the recorded waiting times for 15 randomly selected walk-in customers and determined their mean waiting time was 15 minutes. Got a lot of 15s here. And the standard deviation was 4 minutes. Assume the waiting time is normally distributed. The 90% confidence interval for the population variance. So as soon as I see variance, I know that this is my chi-square. So this is the one that the data is kind of bunched up and then it skews out, that it is not symmetric. And so if I'm doing a 90% confidence interval, then I know this is 0.90. I know that these two pieces, this is 0.05 and 0.05. But how I read the table is this chi-square value will be 1 minus that alpha divided by 2, which is 0.05. So this will be in the table 0.95. All right, so, and the reason why is you read the area to the right, so it would be this area plus that area, and that's where the 0.95 is coming from. But you can just use the 1 minus alpha divided by 2. So looking this up with degrees of freedom of 14, I would get 6.571. This chi-square is found by looking up alpha divided by 2, which is 0.05, and hence in the table you should get 23.685. And now you just plug everything into your formula. So n is 15 minus 1. The standard deviation, there it is, the standard deviation is 5 squared. I don't know why I wrote 5. 4 squared, I'm looking right at it. And then divided by, this is the larger value, so 23.685, and this interval is about my population variance. So the other side will be 15 minus 1, 4 squared, and then over the 6.571. And if you throw all this in your calculator, you should see you'll get the interval 9.46 and 34.09. All right, next item up for bid. This is a proportion. So we want a 90% confidence interval. Now, that was a horrible looking graph, eh? 90%. So that means these values are going to be 0.05 and 0.05. So I'm looking up 0.05 in my table, and this is the 1.645. I plug in everything it gives to me. So it says a random sample of 250 taken and 40% of the sample on an iPhone. So that is my p hat, 40%. My z values are negative 1.645 and positive 1.645. 1.64, oops. My p hat again is 0.4, so my q will be 0.6 when minus that value, and then divided by my sample size, 250, and this is my interval about the population proportion. And so then I write all the same stuff on this side, but plus my 1.645 and 0.4, 0.6 to 50. And when you throw that in your calculator, you should get 0.35 to